All right, we were on the verge of taking the second derivative of this function because we wanted to know what its concavity was. And I'm just going to copy and paste this business. Actually, let's only do the first two lines, right? No, come on. First two lines right here. Let's copy and then come all the way down here, taking the second derivative, and then paste it. Boop. All right. And now let's find the second derivative. Much easier to find the second derivative when it's not in factored form, of course. Okay, multiplying, leapfrogging those powers down. Let's see, I'm going to have 20 ninths x to the, subtract 1 from that exponent, negative 1/3. Right, leapfrog that power down, minus 29 x to the negative 2/3 power. All right, and I want to factor again because it's going to make it easier for us to find those possible points of inflection. So pull out our 29ths. X to the smaller exponent is going to be negative 2/3 power. Boop, boop, boop. All right, I don't have to worry about the 29ths, but let's see, I have x to the negative 1/3 divided by x to the negative 2/3. I'm going to subtract those exponents, so it's 1/3 minus a negative 1, positive, no, negative 1/3 minus a negative 2/3 makes plus 2/3. That's 1/3 power. Yes, okay. And then finally minus 1. Okay, and then maybe we clean this up by bringing this guy down to the denominator and leaving this 9 down in the denominator too, I think. 20 x to the 1/3 minus 1 over 9x to the 2/3 power. Nice. All right, add an extra page because you're going to run out of room. We want our possible points of inflection where they happen where this second derivative is possibly equal to 0 or undefined. Is it possible that this thing is undefined? Sure is, because with that negative exponent, we have x to the 2/3 down on the bottom. So f double prime of x is undefined, and x is equal to 0. And you know what? That's 0, 0. But we already know that this is a relative maximum, so this one is not going to be not a point of inflection. Here's one of those cases where if you were going to try to do the second derivative test, the second derivative test would fail on this particular example because the first derivative would be equal to 0 here, and so would the second one, and so the test would fail. All right. So we still have another possible one, and that is from the top being equal to 0. It's where x to the 1/3 minus 1 is equal to 0. So add the 1 over, cube both sides, x is equal to 1. All right, let's see. What's f of 1? I'd have 1 to the 5/3 power minus 5, 1 to the 4/3 power, which is 2 minus 5, which is a negative 3. We've got 1 comma negative 3. What could possibly happen at this point? Point of inflection? Did you notice how I did an inflection when I said that? How do I tell whether or not I have a point of inflection here? I'm going to do a test for concavity. That's not how you spell that word. That looks right. Okay, so once again, we're going to use the from negative infinity to positive infinity for intervals. Going from negative infinity, and we do need to still include 0 here. And you will see that we're not going to have a point of inflection here with the test. It'll all bear out. Let's say, for example, you didn't notice Oh yeah, we already have a relative maximum here, so we're not going to have a point of inflection. Let's just pretend like you didn't notice it. So you're going to do a test for it, and the test is going to tell you anyway. Going to go up to 1, from 0 to 1, and then finally 1 to infinity. Pick some test values like -1. How about 1/8? And then 8. Yeah, all that sounds good. Again, chose those numbers because they're perfect cubes. Where do they go this time? In the second derivative, the factored form, because we want to know positive or negative for that thing. Where is this thing? So first up is -1. We want to plug it in here. So the bottom, since it is to the second power, it's to the 2/3 power. This is always positive down here in the bottom. You don't have to worry about it. It's only the top. So if I stick in a -1 here, this is a negative. -1 is still negative. This whole thing is negative and it's concave down. Negative f of x concave down. It's a CD. Let's stick in a 1/8. Okay, when I stick in a 1/8 here, 1/8 cube root of that is a half. Half minus 1, it's a negative number here. Whole thing is negative still. Still concave down. So this is what I was talking about before. If we didn't notice that 0 was a relative maximum, the test for concavity will show us that it's not a point of inflection anyway. Okay, and then finally, if I stick in an 8, boop, that'd be a 2. -1's a positive. All this thing is positive. And now it is back to being concave up. I said back. I mean, it's the only time it was concave up. We are concave down and we are concave up. We have ourselves a point of inflection at 1, -3. Justification here. With a little bit of weird zooming going on, since f double prime changes signs at x is equal to 1. All right, let's put all of that stuff together, shall we? Okay, on our first interval from -infinity to 1, it is concave down and, I said 1, I think it's up to 0, and increasing. So concave down and increasing. Over this small little portion here, it's got to be going upwards and it's got to be going concave down. Okay. Okay, and this is the maximum, so it's got to start. Are you kidding? Let me try that again. All right, so, and then it's got to come back down. All right, now, this is a maximum point, and I know that this has got to be a smooth turn here because the derivative existed. There weren't any points where the derivative did not exist. And one of the things that I forgot to put in here is 1, -3, because this is our point of inflection. It's going to continue to be concave down here, but now it's going to be concave up, but still decrease until we get to this relative minimum point down here. Like, man, was that glorious or what? Okay, and then finally, it's going to increase. It's going to start increasing until we get to this, I guess this intercept that's over here at 15.625. All right, let's give that a shot, huh? See how good of an aim I am. All right, there we go. Perfect, perfect. And when I say perfect, I mean, this is almost like you're looking at a calculator screen, right? A graphing calculator screen. It's about that good. As a matter of fact, let's take a look at the actual graph right there. All right, so there's our two intercepts, exactly where we thought that they were going to be. Here's our relative minimum point down there, and there was our point of inflection, all of that stuff. That's exactly what we found. And then here's our graph. Hey, once again, I think we did a pretty good job. And you might think that it's sharp, but as we discussed, it's not sharp right there at that particular point. Let me go back to ours and let's take a look at it again. Nice, right? Fantastic.